Let's look at the mapping diagram. We have an input set of 1, 2, 3, and 4 paired with an output set of 0, 1, and 2. Now this is a function. It is a legitimate function. But if I put an input of 1, I get 0. If I put an input of 2, I get 1. If I put an input of 3 or an input of 4, I can get 2. What this says is, in a function, an output can be paired with more than one input, right? In other words, 3 can lead to 2 and 4 can lead to 2. But the reverse is not true. In other words, an input cannot be paired with more than one output. In other words, you can't have 3 causing both 1 and 2 at the same time. Okay, that's not a function. It doesn't work that way. Okay, this is extremely important. This is what defines what causes a function or does not cause a function. Okay, so let's look at example 2. Tell whether the pairing is a function. So is the pairing a function? Well, let's look. Part A has this little mapping diagram where you have an input and you've got an output. And the input is 0, 5, and 10. And the output is 2, 3, 4, 5. And we're told that 0 can lead to either 2 or to 3. 5 gives you an input of 4, an output of 4, pardon me, and 10 gives us an output of 5. Is that a function based on our definition of function? Well, let's look at the definition of a function. Is an output paired with more than one input? No. Is the reverse? Do I have an input that has 2 outputs? 0 apparently can cause either 2 or 3. The output, apparently 2, depends on 0 and 3 depends on 0 at the same time. That is not a function because this input cannot cause 2 different outputs. Therefore, this pairing is not a function. Okay, because this, right, causes 2 outputs. Let's look at a different one. And this one, instead of being as a mapping diagram, is actually done as a table. Where you have an input and output. So when you have an input of 0, you get an output of 0. When you get an input of 1, you get an output of 2. and you get an input of 4. You get an output of 8, an input of 6. You get an output of 12. Is this a function? Well, is there one input that's paired with more than one output? Nope. Each input in this situation has just one output. So clearly, it is a function. Okay. All right. So I would like you to pause the video for a minute, and I want you to do guided practice number 3. Okay. When you're done, I want you to pick up where we left off with the video. Okay. So we've talked about what is a function, when is it not a function. We're going to go through this again. And we're going to use as this the basis of the definition of a function. The range depends on the domain. In other words, the cost of gas depended on the number of gallons, right? The range depends on the domain. The output depends on the input. Y depends on X. And we're going to learn a new word. Y is the dependent variable. Why? Because it depends on the independent variable. In other words, what causes what? What causes what? What depends on what? The dependent variable is Y. It depends on X. The output depends on the input. Okay? It is important, very, very important to understand these pieces. So, how does this work? We're going to talk a little bit next. I'm going to pause here, and we're going to talk about function rules. But I want you to memorize this, okay? As you look at this video, I'm going to do a quick little third video. I'm trying to make them shorter. I want you to memorize the range, the output, Y, the dependent variable. These all mean the same things. Domain, the input X, or the independent variable. The independent variable isn't caused by anything. The dependent variable, the output, the range, is caused by this. This causes this. Okay? The independent variable causes, right, the dependent variable. Okay? It is important to know that this causes this. This depends on this. If you understand that, you're on your way to understanding functions. I'm going to finish in just a minute.